Hey everyone! Gearing up for the CompTIA A Core 2 exam? Well, you are in exactly the right place. Today we're taking what might look like a bunch of dry administrative rules and transforming them into your ultimate IT survival playbook. We are laser-focused on Domain 4, operational procedures. Let's dive right into this explainer and see how mastering this framework is the absolute secret to not just passing the exam, but actually keeping your job in the real world. Here's our agenda for today. 1. Documentation and change management. 2. Safety, power, and backups. 3. Incident response and law. 4. Professionalism in IT. And 5. Automating with scripting. Master these 5 pillars and you're golden, because this domain is worth a whopping 21% of your entire exam. All right, Section 1. Documentation and change management. The rules of engagement. You know the saying, right? In IT, if it isn't documented, it technically never happened. Documentation is the structural foundation that keeps you from getting lost, or worse, getting fired. So let's talk about the rule books. An SLA, or Service Level Agreement, is an ironclad contract. It basically guarantees that a vendor will fix an outage within a strict time frame, maybe 4 hours, and it lays out the exact financial penalties if they mess up. Contrast that with an SOP, or Standard Operating Procedure. If an SLA is a legal contract, an SOP is just your everyday cooking recipe. It gives you those step-by-step instructions for routine tasks so your troubleshooting is consistent every single time.
So, let's put that into practice with a classic scenario you're totally going to see on the exam. Picture this. You've got a core switch that desperately needs updating. The question is, how on earth do you avoid crashing the entire corporate network in the process? What's your very first move? Spoiler alert, you can't just unplug it and cross your fingers.
And this brings us right to the change management lifecycle. Think of this process like air traffic control for your company. Without it, changes literally crash right into each other. First, you submit a request, then you assess the impact on the risk. Next, you absolutely need approval from the CAB, the Change Advisory Board. After that, you test it in a sandbox. That's your safe, self-contained flight simulator where you can crash the plane all day without taking down the real network. Finally, you implement it during a maintenance window with a strict rollback plan ready to go if things blow up. And you document the whole shebang. Seriously, a rollback plan is your exact procedure to return the system to its original state. Don't touch a server without one. Moving right along to Section 2, Safety, Power, and Backups, Crisis Response. Okay, when you're dealing with a physical crisis, your absolute first stop is the MSDS, or SDS, the Materials Safety Data Sheet. OSHA mandates this thing, so think of it as your cookbook and first aid manual combined for anything hazardous in IT. It tells you exactly what kind of nasty stuff is inside a server battery or a toner cartridge, how to handle a spill safely, and how to get rid of it. You definitely cannot just toss these things into the regular break room trash. But what about digital crises? Backups are your ultimate insurance policy. Check out this comparison between differential and incremental backups. A differential backup copies everything that has changed since the last full backup. It's kind of slow to run day to day, but super fast to restore because you only need 2 puzzle pieces, the full backup and the latest differential. Incremental backups, on the flip side, copy only what changed since the very last backup of any kind. So they run incredibly fast, but they are a massive pain to restore because you have to piece together the full backup and every single incremental backup in order. Memorize this distinction. It is a huge help for those highly testable scenarios on recovery times. Now for Section 3, Incident Response and Law, the Aftermath. Let's say a security breach happens. The absolute golden rule of incident response is the chain of custody. Think of this like a hyper-detailed package tracking number, but for digital evidence. You have to meticulously record exactly who touched the evidence, when they had it, and what they did with it. If this chain breaks, or even if there's a tiny unexplained gap, your evidence is completely useless in a court of law. Case closed. And when you're collecting that digital evidence, you are literally racing against the clock. This list right here outlines the order of volatility. Volatile data disappears ridiculously fast. You have to capture the most fleeting data first. Start with the CPU registers and cache, then move to the RAM and routing tables, down to the swap or page files, then the physical hard drives, and finally backup tapes. Always, always gather what vanishes fastest before you ever lay a finger on the physical drive. So what happens when a machine gets heavily infected with malware? The sources highlight this aggressive but totally vital industry best practice. Nuke it from orbit, wipe the drive, and reimage. Trying to manually clean a severe infection is super risky. It leaves you vulnerable to hidden malicious code. Wiping the drive completely and dropping a clean, fresh image on it is simply the safest, most reliable way to guarantee that the threat is actually gone. Throughout all this chaos, remember that you are surrounded by sensitive data. PII, or personally identifiable information, is literally any data that can point back to a specific human being. Protecting this stuff isn't just a best practice, it's a strict legal mandate. Understanding privacy licenses, EULAs, and how to handle data responsibly is a huge, non-negotiable part of a modern IT pro's daily job. Let's pivot to Section 4, Professionalism in IT Support, Human Skills. Look, fixing a computer is really only half the job. How do you handle a totally frustrated user? If you fix their laptop but completely alienate them in the process, you kind of failed as a support tech. We use the LISTEN method. Listen without interrupting. Inquire to clarify. Sympathize with their frustration, think about the solution, evaluate your options, and note the resolution. The big takeaway here? Drop the technical jargon. You are essentially a translator between the machine and the client. Don't tell them the DHCP scope is exhausted. Instead, tell them you're freeing up space for more devices to connect. Speak their language.
Finally, Section 5, Automating with Basic Scripting, Future-Proofing.
If you want to future-proof your career, you got to learn to talk to the computers. Automation through basic scripting is your absolute secret weapon against boring, repetitive manual tasks. A script is really just a digital recipe. For the exam, you must memorize these essential file extensions. .bat is your classic Windows batch file. .ps1 is PowerShell. That is an amazingly powerful tool for modern Windows administration. .bbs is Visual Basic Script. Over in Linux and Unix land, .sh means a shell script. .py is Python, which is basically the king of cross-platform automation, and .js is JavaScript for web interactivity. Tie the file extension to its environment, and you'll breeze through these questions.
And there you have it. We've covered the foundations of operational procedures, and you now hold the survival playbook. So here's the big question. How will you use these concepts, from enforcing the chain of custody to nailing that perfect change management rollback plan to stop a real-world disaster on your very first week at the help desk? Keep this framework locked in your mind, and you're going to absolutely crush the Core 2 exam. Keep learning, keep focusing, and I will catch you in the next explainer.